We can consider any file to be consisting of a set of logical blocks. When the file is stored on a disk, each logical block is mapped to one of the physical blocks on the disk. Now let's discuss which are the different ways of allocating these physical blocks to the file by utilizing the disk space effectively and allowing file access quickly. The first method is contiguous allocation. Here, each file will be given a set of contiguous blocks on the disk. Here, the file count has two logical blocks. Hence, starting from the disk block address 0, it will occupy two physical blocks, two contiguous physical blocks on the disk. Similarly, the other files also occupy contiguous blocks on the disk. Now, how will be the directory entry? The directory entry keeps the starting block address of the file and the length or the number of physical blocks occupied by the file. The file count starting block address is 0 and it occupies 2 blocks from the address 0. And the file tr starting block address is 4 and it occupies 3 contiguous blocks. And the file list starting block address is 8 and it occupies 4 physical blocks, 4 contiguous physical blocks. Now, what are the advantages of this method? This method is simple to implement and the file can be accessed easily, whether sequential access or direct access of any block, it can be accessed easily. And what are the limitations? The main limitation is external fragmentation. As time passes by, while the files are being allocated and deallocated, the free disk space will be broken into chunks or fragments, where no fragment is large enough to hold any file. Suppose we have a new file which requires 4 physical blocks for its storage. Here we have enough space, enough number of free blocks to store this file, but the available blocks are fragmented across different portions of the disk space and we require 4 contiguous physical blocks. Hence, we won't be able to keep this file on the disk. So wherever we use contiguous allocation, we'll have the problem of external fragmentation and the solution is compaction, but it's very expensive. Another major difficulty is finding a contiguous space for a file with maximum speed and by utilizing the disk space effectively. First fit, best fit and worst fit are the common strategies used to select a free hole from a set of available holes. But here one another issue is the space required for the file may not be known while the file is being created. Also, if it is known, sometimes the file may grow over time. So to overcome all these limitations of contiguous allocation, we go for non-contiguous allocation.